Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at the factor theorem. So, first of all, what is the factor theorem? Well, the factor theorem is a way of finding linear factors of a polynomial. Okay, so we know what a polynomial is. A polynomial is a quadratic, a cubic, a quartic, anything like that is a polynomial. Linear terms are also polynomials. And it's basically a way of finding linear factors of polynomials. Okay, so linear factors, linear being the highest power of an algebraic term is 1. So something like ax plus b, or ax on its own maybe, or just x plus b. Okay, we've just got x and some other constant maybe as well, or some multiple of x. That is what a linear factor is. Okay, so it's a way of finding linear factors of maybe a quadratic, if we're taking the polynomial to be quadratic. Okay, so let's have a look at what the definition of the factor theorem is. Let's have a look. So if we have f of x and we say that is a polynomial, then this is true. Okay, if we have some constant p, okay, and f of p is 0, so when we substitute p into our polynomial being a quadratic or a cubic, okay, when we substitute p, if f of p is 0, then x minus p is a factor of f of x. So the constant that we're substituting, if we substitute that into our polynomial, into f of x, and we get the value of 0, then x minus p, here we had a positive p, x minus p, that is a factor of f of x being the polynomial. We can also say that the other way round, so if we know that x minus p is a factor, then f of p is 0. Okay, so here we were starting off with f of p being 0 and getting that x minus p is a factor. Here we're saying if we know x minus p is a factor, we can work the other way and say f of p is 0. Okay, so take for an example, we have a quadratic, and let's say this is f of x. Okay, so f of x is our quadratic. If we set that quadratic equal to 0, then we can work out what the values of p are going to be to make that quadratic 0. We're basically just solving the quadratic. Okay, so when we do that, we can factorise to give us those two brackets, and then we can get from either bracket being equal to 0, we can get x is minus 1 or x is minus 2. Okay, so really we can kind of use the factor theorem here to help us. We started off with our quadratic and we set it equal to 0 to work out the two values that when we substitute into f of x here give me 0. Okay, so basically we're saying here x equals minus 1 gives me 0. So what I'm saying here is that f of minus 1 is equal to 0, and here I'm saying f of minus 2 is equal to 0, because we know when we set the quadratic equal to 0, these are our two solutions, and so when we substitute minus 1 into the quadratic, we get 0, and when we substitute minus 2 into the quadratic, we get 0. So that's all these two little statements are saying down here. So we know f minus 1, or f of minus 1, is equal to 0, so when x is minus 1, the quadratic is 0. So that's the case, we've got the first bullet point here. That is the case, so then x minus p is a factor, and we can see that here. X minus 1 is x plus 1. That is a factor of our quadratic. When we factorised, that was one of the brackets. So we've kind of started off here with f of p being equal to 0, f of minus 1 is 0, so x plus 1 is a factor. And we can also go the other way here as well. X plus 1 is a factor because it's in our factorised form, and so we could say f of p must be 0. Minus 1 minus p here, so we have a plus 1, so we need to take the opposite sign. So we're going to have minus 1 as a f of minus 1 is 0. Okay, so that's just me solving a quadratic and kind of showing you what I mean by the factor theorem. Now let's actually have a look at an example and how we can use the factor theorem to help us. So we're being told to use the factor theorem, and it says show that x minus 2 is a factor of this polynomial. It's a factor of x cubed plus x squared minus 4x minus 4. Now, I've got a little note here. It says we can also show this using algebraic division. So if you want to do it by algebraic division, which you might want to do, it does say using the factor theorem, but maybe have a go just for your own sake at algebraic division. Consider remainders. If x minus 2 is a factor, and we kind of know that, we're just being asked to show it, okay, so we need to show it. We're going to start off by doing some maths proof basically, but just think about algebraic division and consider remainders. If x minus 2 is a factor of this cubic, what will the remainder be? We know it is a factor because we're being asked to show it, so think about what the remainder will be if you want to do it by algebraic division. But I'm going to do it by factor theorem. I was just saying you can do it by algebraic division if you want to. But have a go at factor theorem as well. See what you can do with one of the 2 bullet points up here, okay? See what you can do with that. So pause and have a go, and when you're ready, press play and we'll work through the answer. Okay, I'm going to do it by factor theorem. If you did it by algebraic division, just for your own sake, then you would have got a remainder of 0. And because you've got a remainder of 0, that clearly shows that x minus 2 goes into this cubic nicely, okay, with remainder 0 is what I mean by nicely, and so it definitely is a factor. But in the question, we're being asked to use the factor theorem, so we need to do that. So I'm kind of going to assume that this polynomial is a function, and I'm going to let f of x be the polynomial. Okay, so we'll start off by doing that. Let f of x equal the polynomial. So x cubed plus x squared minus 4x minus 4. Okay, so we've assumed it's a function. I've let it be f of x, and that just helps my working be a little bit neater. Okay, then what I'm going to do is, well, if x minus 2 is a factor, we're being asked to show that, so we need to make it a factor somehow. We need to do our kind of proof or our steps to show that it is a factor. If it is a factor, then remember here, the second bullet point, it says if x minus p is a factor, so if our linear function here, if you like, is a factor, then f of p must be equal to 0. So f of this p here must be equal to 0. So, let's write that here. If x minus 2 is a factor of f of x, then f of the opposite sign, so f of 2, must be equal to 0. Now, we know what f of x is, it's this cubic, so all I'm going to do is substitute in 2 into here and see whether we get 0. If we do get 0, then x minus 2 is a factor. So, f of 2 will be equal to 2 cubed plus 2 squared minus 4 lots of 2 minus 4. And when you put that into your calculator, you get 8 plus 4 minus 8 minus 4. And we can clearly see that the 8 and the minus 8 will cancel, and we'll do it in green. The 4 and the minus 4 will cancel to give me 0. Okay? So we can say, and so x minus 2 is a factor of f of x. Because when we substituted 2 into our polynomial, we got 0. Okay, so that is kind of our finishing statement at the end. Let's make that a straight line. Okay, that's all we have to do there. So if, again, like I said, you did algebraic division, you would have just divided x minus 2 into this polynomial and got a remainder of 0. But at A level, do be careful, because just like here, we were asked to use the factor theorem. So in an exam, if you did algebraic division, you wouldn't get the marks. You just can use algebraic division. We just needed to do it by the factor theorem though. Okay, so let's have a look at how we can factorise cubics using the factor theorem, and we'll have a look at this through an example. I don't want to write out a method because I don't want to confuse you. We'll just do it through an example. So we don't really know how to factorise cubics unless we can take out a factor of x from all of the terms, okay? If we had something like x cubed minus 10x squared plus 6x, we could take an x out of all of those. X times x squared minus 10x plus 6, and then we can factorise that quadratic if it factorises, okay? It might not factorise there, which I don't actually think it does because I've just pulled out the numbers, but I'm just giving an example, okay? That is just an example. We would have been able to factorise that quadratic and just multiply it all by x to give us, that cubic, okay? But let's say, for example, we want to use the factor theorem. So I have a cubic here that we want to factorise. We've got x cubed, minus 10x squared plus 19x plus 30. And we're asked to factorise that. So let's have a look through an example. The first thing I'm going to do is I'm just going to try values of x, because what I want to do is I want to find a value of x that makes f of x 0, okay? Now it's always useful to start at x equals 1. You could try and start at x equals 0, but hopefully you can see that when x is 0, all of my x terms are 0. So if x was 0, that would disappear, that would disappear, and that would disappear, and we'd just be left with 30. So f of 0 is 30, not 0. So that's no good. Now if we try x is equal to 1, it's kind of like a trial and error thing here. We can substitute 1 into here. We would get 1 minus 10 plus 19 plus 30, which gives me f of 1 is 40. That's no good because we're trying to find our f of whatever to be 0. So x equals 1 is not going to help us, okay? We're not going to be able to use the factor theorem on x is equal to 1. So we could go up and try 2, and if you do that, you will see that that is also not equal to 0. But if you go down to minus 1, you can see that we do get f of minus 1 is equal to 0. Because we get minus 1, minus 10, minus 19 plus 30, put it in a calculator, f of minus 1 is 0. And so what that tells me, going back to the first bullet point here, we've got p to be minus 1 here. I'll put that here. This is our example. P is minus 1. So f of minus 1 is equal to 0, then tells me that x minus p, so x plus 1, is a factor of f of x. So going back down here, I can see I've got f of minus 1 is 0. So by the factor theorem, x, change the sign because we've got minus 1 here, so it's going to be a plus 1 here. X plus 1 is a factor of our polynomial f of x. And I'll write that on here actually, a factor of f of x. Okay, so hopefully that makes sense so far. We're just trying to find a value of x that when we substitute it into f of x, we get 0 so that we can use this factor theorem trick here. Okay, let's continue. So what that tells me now is I can write f of x as some multiple of this factor. Okay, I can write it x plus 1 times, and it's a quadratic here because we had a cubic. We started off with a cubic, and we know x plus 1 is linear, so multiply what by a linear to give me a cubic, that must be a quadratic. Okay, if we factorise out a linear, which is what we're doing, from a quadratic, we're going, from a cubic, sorry, we're going to reduce the power, or the highest power, by 1. We've gone from a cubic, multiplied by a linear, we need to then multiply by a quadratic to get that cubic back. Okay, so hopefully that makes some sense. And a factor really just means we can kind of factorise it out. We've factorised out x plus 1 from this cubic, so we need a quadratic to be multiplied by it. So I've got here A, B and C are an element of the real numbers, so they're constants, okay? And we really just need to find those constants, and then we can do the trick that I mentioned at the start, which is then factorise this quadratic if it factorises. So, how can we find A, B and C? Well, what I'm going to do is I'm going to divide f of x by x plus 1, because if you remember from algebraic division, what we could do is divide this, or a factor of this cubic, we can divide that factor into this cubic to give us the quadratic here, because we'll end up with our x plus 1 multiplied by our quadratic will give me this. In other words, we could write f of x divided by x plus 1, which is what we're going to do with algebraic division, will give me that quadratic, and then we just multiply up by x plus 1. I mentioned that in a previous video. So let's do algebraic division. When we do that, I did grid method here. So I put my x plus 1, which is my factor, is what I'm dividing by. I put that on the left hand side here. And then I started with my cubic and I said x times what gives me a cubic, that's 1x squared. Then multiply to give me the x squared. And then think, right, I've got an x squared here. I don't want 1x squared, I want minus 10x squared in my cubic, that's what I have. So I need to minus 11x squared, and we work along the diagonal like that, okay? So then we say, what do we need to multiply x by to give me minus 11x squared? That clearly has to be minus 11x, okay? If you're unsure on this grid method division, then have a look at the previous lesson. And then we did some multiplication, so minus 11x multiplied by this plus 1 gives me the minus 11x. Work along the diagonal, I need to add 30x to give me 19x, which is what I want in my cubic. So then we say x times what gives me 30x, that clearly has to be 30, and then do the multiplication. 30 times 1 is 30, and we know that the constant here is 30, we'll do that in red actually. There's the constant of 30, and we have a constant of 30 here, so the remainder is 0. So then my answer, or my quotient if you like, is this at the top of the grid. That is the quadratic that we get here. So my value of A is 1, my value of B is minus 11, and my value of C is 30. So we can write f of x now like that, okay? And then all we need to do is just factorise this quadratic if we can. So factorising that quadratic, you could do that if you want to. You get x minus 5 and x minus 6. Multiply that out, you get the quadratic that we need. And so we can write our cubic like that. Remember, f of x was the cubic, so we've got 3 brackets. 3 brackets, they're all linear x, so we can just multiply them out, will give us the cubic. And if we multiply them out, we will get the cubic that we started with. Okay, so hopefully that makes sense. That's how we can use the factor theorem to help us with our factorising cubics. You basically need to find a value if you're not given one already, or if you're not given a factor. You need to find a value that makes the cubic 0, then work out then from that what your factor will be. Your linear factor will be x with the opposite sign, so x plus 1. Minus 1 made it 0, so our factor is x plus 1. And then if it's a cubic that you're dealing with, you can multiply it by a quadratic to get that cubic, but you don't know what the constants are here. So then we need to divide x plus 1 into our f of x to get this quadratic. Hopefully this makes sense here. Do that by long division. I use the grid method there. And then factorise this quadratic that you get, if you can, to factorise the cubic fully. Okay, hopefully that makes some sense. Let's have a look at another example. So example 2, we've got 2 parts. Part A says fully factorise 2x cubed plus x squared minus 18x minus 9. So it's a cubic. This time we've got a 2 at the start of our cubic. Won't make much of a difference. So see what you can do with factorising that. And then if you can, use your answer because it says hence, so do part A, get your factorised cubic, and then sketch the graph of y is equal to the cubic in part A. Okay, so pause and have a go, and press play, and we'll work through the answer. Okay, I am going to start by trying to find a value that makes the cubic 0. And again, I'm going to assume that my cubic is a function, or I'm going to let it be a function because f of x is a function. So let's do that. Let's let f of x equal 2x cubed plus x squared minus 18x minus 9, okay? I need to find a value that I substitute into there to give me 0. Now, if we try 1, let's see what that will do, because it's always a good number to start with. So f of 1 will give me 2 times 1. Cubing it doesn't make a difference, but we'll still put it there. Minus 18, lots of 1, minus 9, okay? That is then 2 plus 1 minus 18 minus 9, which clearly does not equal 0. Okay, so f of 1 is not helpful, does not give me f of 1 equals 0, so that's no good. Now, I would then try minus 1, like we did in the previous example. F of minus 1 will be 2 times minus 1 cubed, plus, and it's minus 1 squared, minus 18, lots of minus 1, minus 9. And I think this does give me 0. Oh no, it doesn't. It gives me 8, okay? So when we substitute that, we get minus 2 plus 1 plus 18 minus 9, and that's going to give me 9 minus 2 is 7 plus 1. Yeah, that gives me 8. So again, that's no good, okay? You can try some other values as well. If you go further down, I'll give you a hint, that's not going to help. You need to go further up and do some trial and error. I have the answer here, so I'm going to jump to f is equal to 3. F equals 3 gives you this, 2 times 3 cubed plus 3 squared minus 18 lots of 3 minus 9. Put that in a calculator, you do get 0. So that is going to help us work out what a factor of our polynomial is, or our f of x. Okay, f of 3 gives me 0. So because f of 3 is equal to 0, the factor theorem says this. Says x minus 3, and that's a bracket there, x minus 3 is a factor of f of x. Okay, so in other words, like in the previous example, we can then say f of x is equal to some multiple of x minus 3 multiplied by ax squared plus bx plus c, where a, b and c are some constants and they are real constants. Okay, that's how we write it there, element of the reals. So we don't know what this quadratic is going to be, we just know it's going to be a quadratic because we've got a cubic and we have a factor that is linear, so we need to multiply it by a quadratic to give me that cubic. Okay, so now what we need to do is work out a, b and c. We need to work out what the quadratic is, and to do that I will use long division. So I'm going to do this using the grid method. You can do it any method that you like. So we multiply here, we're dividing by x minus 3, and we are starting with, in our f of x, 2x cubed. So that's what we want here. And anything that kind of goes here, if you've seen the previous video, makes up our cubic that we have. So I need to think, what do I multiply x by to give me 2x cubed? Well, of course, that is 2x squared. Multiplying that will give me minus 6x squared. I don't want minus 6x squared, I want plus x squared. So I'm going to need to add to that 7x squared, okay? We work along the diagonal to make up the x squareds that we have in f of x, okay? So then what do I need to multiply that by? I need to multiply it by 7x, because 7x times x gives me the x squared, and then do the multiplication there. That's going to be minus 21x. I don't have minus 21x, I have minus 18x, so I'm going to need to add 3x to that, okay? And that works nicely there. So I'm going to need to multiply that by a positive 3 here. 3 times x gives me positive 3x. And then 3 times minus 3 is minus 9. I've now got to the constant term here. So I'm going to have a look at my remainder. And it's going to be a remainder of, well, it's actually going to be a remainder of 0, because we have minus 9 in f of x. And in my grid multiplication, we have minus 9 there. And so that then must be a remainder of 0, because our constants add up, okay, or they're the same. So this on the top here is then my quadratic. So I'm going to take that and replace it with what was already there, my a, b and c. Okay, I now know what a, b and c are. So f of x is x minus 3 multiplied by 2x squared plus 7x plus 3. Okay, and it says a key word in the question. It says fully factorize. So we have factorized, but we haven't fully factorized, okay? We've factorized because we have a linear times a quadratic, but we can go one step further. We can factorize this quadratic. And when we factorize that quadratic, hopefully you could do that yourself. We'll have x minus 3 from this bracket here, and we'll multiply it by 2x plus 1 times x plus 3, okay? That is then fully factorised, because we have 3 brackets, which will give us our cubic, and we've got the 3 linear factors, so we've fully factorised there, okay? Hopefully that makes some sense, and it's not too tricky once you get into the process. Part B says, hence sketch the graph. So we are sketching the graph of this cubic. Now this cubic we have just fully factorised, and it says hence, so we want to use our answer to part A. So we want to sketch this f of x here. It's exactly the same f of x in part A, but it's factorised, okay? So all we can do is use our knowledge on roots, okay? So part B, let me do a sketch like this. There's my x and y axis. Don't forget to label them. And all I'm going to do is find the roots of this cubic. It's a cubic because we were told in part A the highest power was 3, but we can also see it's a cubic because we've got 3 factors here. So we'll have an x times an x will give me an x squared, and then we'll times it by this x to give me an x cubed, okay? So if we set it equal to 0, we will then find the roots. And if we set each bracket equal to 0, this will give me x is equal to 3. This will give me x is equal to minus a half, and that will give me x is equal to minus 3. So hopefully you're okay with finding roots of cubics at the minute, okay? So now we have 3 roots. Roots are where the graph intersects the x-axis. So we're going to have roots here, and I'll draw them on in blue. So we're going to have a root of minus 3, a root of minus a half, and a root of 3, which is going to look something like that, okay? And then all we need to do is draw on our graph. Is it a negative or positive cubic? Hopefully you've watched the video on that. It is a positive cubic because we can see we have a positive coefficient of our x cubed there. So it's going to start down here, it's going to come up, pass through the root of minus 3, but then come back down to pass through the root of minus a half, go down and then back up to pass through the root of 3, and then carry on all the way up there. And that is the rough shaping of the cubic. Okay, the final example for this video says, given that x plus 1 is a factor of 4x to the power 4 minus 3x squared plus a, find the value of a. So use the 2 bullet points at the start of this video to help you. We are given, in this case, that x plus 1 is a factor. We're not being asked to show it is a factor. So we can just use the fact that x plus 1 is a factor. If x plus 1 is a factor, what does that say about f of minus 1? What's that going to be equal to? Think about that and then use that to find the value of part A. So pause and then press play when you're ready for the answer. Okay, so I just said think about f of minus 1 because, and I'll write it here, because x plus 1 is a factor, then we can straight off talk about f of minus 1 being equal to 0, and that is by the factor theorem. By the factor theorem. It's always useful to state what you're using. So here I am using the factor theorem, okay? So f of minus 1 is 0. Let's substitute minus 1 into what I'm calling f of x. Okay, so let f of x be equal to our quartic in this case, because the highest power is 4. So 4x to the 4 minus 3x squared plus a. Then if we substitute minus 1 into that, we know we are going to get 0 because x plus 1 is a factor. So f of minus 1 is 0. So let's substitute that in. F of minus 1 is going to be equal to 4 times minus 1 to the 4 minus 3 times minus 1 squared plus a. But we can use this piece of information here, in fact we'll highlight it in grey, that piece of information there to say that that must be equal to 0. So minus 1 to the 4 is going to be 1, so that's just going to be 4. Minus 1 squared is just 1, so that's going to be minus 3 plus the a will be equal to 0. Okay, we'll put a little arrow there. So then that tells me, well, 4 minus 3 is 1, 1 plus a is equal to 0, and then take a 1 from both sides, or you could take a from both sides and multiply both sides by minus 1. Doesn't really matter. I'm just going to say a must be equal then to minus 1 for this equation to be true. That's my value of a.